Maybe that'll work. Cool. Yeah, if that ever happens in your remote, like text me or something, because it'll at least buzz and I can see if it's causing any trouble. All right, awesome. So we're gonna look at some chapter 3 stuff now. So we've done some basic, we're gonna set values, and then we wanna have that logic that says, hey, if something's true, do this, otherwise do something else. Right, so now we need to look at some other, working with other data types as we go. So of all of, they're called primitive data types, so that Java is actually storing the value directly. So in Java, there are objects and there are primitives. There's only 8 types of primitives, and most of the time, we're only going to use ints and doubles. So like an int, you know, some number, these are whole numbers, right? Like 42. That's an int. Doubles we did, right? Doubles are numbers with decimal places typically. Number with a decimal. That's with a decimal, like 7.7. Sure. And remember, by default, if you put a number with a decimal place, Java's going to treat it as a double. So if you want another type called a float, this is, you know, floating smaller than a double, you have to say F for float. And this is why I hate floats and I just try not to ever use them. Really, this is the only reason, because you have to put an F there and it irritates me. Now, there's nothing wrong with floats, and technically they're good and proper, right? If you don't need the amount of precision that a double gives you. So a floating point value can store 7 decimal places worth of precision. A double can store 16, so it's not actually like even double that, but that's okay. So depending on what level of precision you need, maybe a float might be more appropriate. The reason why it matters is it uses less memory in your computer. So when Java says, hey, operating system, I need a place to store a number, and the operating system will give you some amount of memory. So a double uses 8 bytes of memory. Remember, a byte is 8 bits. So we're taking up 64 bits of memory to store a single value as a double. Now, our computers have billions of bits of memory, right? So a kilobyte is 1,000 bytes, essentially. Depending on who measures it, it's actually 1024, and other people measure it as 1,000, and I just don't understand why. I would just assume 1,000 is fine. So 1,000 is a kilobyte, a million is a megabyte, and a gigabyte is a billion. So when your computer has like 8 gigs of RAM, you have 8 billion bytes of memory, essentially. And that's bytes, not even bits, because it's measured in the 8 bits per byte, so we measure everything in bytes. Except internet speeds, which are measured in bits, which I still don't understand why. Dr. Ball might know. He knows a lot about networking. So, again, takes up more space, but the amount of more space for the things we're doing, we could care less. If you're going to store like millions of them, yes, that really adds up. So at some point, and when you move on to like a data structures and algorithms analysis class, we care, are we using the right amount of space? Because that matters when we want to look at, hey, are we being efficient with our storage? But for the things we do, like even if we have 100 of them, our computer could care less, right? Again, we've got billions of bytes of space in memory. Now, that's a little bit lazy, and yes, it is, and sure, but we have the luxury of being lazy. Years and years and years and years ago, when computers had like megabytes of memory, it mattered. But thankfully, we're in 2021, where your computers can come with 8, 16, 32 gig of RAM, and we just don't care. We're gonna abuse it because we're lazy. Yeah, sorry. That's just kind of how it is. Right. So floats, again, they're smaller, less precision. You can store an individual byte if you so care to. Right. This is a small integer. Right. No more than 127. Right. No less than negative 128. So they're really small. So some people love storing things as bytes. It just drives me crazy. But sure. And with the whole number values, it just works. I don't have to say this is, you know, like add a B for byte or anything silly. But what you're going to get, if you try and store too big of a number, it's going to yell at you. It says incompatible types, possible lossy conversion from int to byte. So the Java compiler, as it's looking at our code, even knows, hey, this number's bigger than a byte. So if we do something smaller, it's perfectly fine. So technically, this 42 is a byte, but we're storing it as an integer. Sure, right? We just know we need an integer value. Life is good. So again, ints take up 4 bits. This is 4 bytes of storage. A double takes up 8 bytes of storage. A float takes up 4 bytes of storage. A single byte, right, is 1 byte. Go figure. You can also do a short value, which is like in between an integer and a byte. So it's, I don't know, slightly larger int. Sure, so that's 2 bytes worth. And not really all that interesting. Just if you need to go find it, you can go look it up. So these are all the numeric ones. Again, we mostly will only use ints and doubles because they're easiest, right? No big deal. If you want a bigger integer, you might use a long. This is a bigger integer. I don't know, let's do some big number here, like 786,197,123,122. Oh goodness, that's right, I have to declare it. Even with an L, right? Longs need an L. Your Java compiler is not smart enough without. And longs are 8 bytes, so it's twice the size of an integer. Sure. Sorry, is it a little higher up? So lots of different types, no big deal. We can store them. Those are all the numeric types. Then we also get 2 more. These ones are used actually occasionally. There's a char type, which is a single character. Now what's cool about characters, so this is just a single, letter is actually wrong because it can store any character value, right? Like a number's a character value, these special symbols, like semicolon is a character. You define characters with a single quote or apostrophes, not the double quote for a string. So anything in a double quote or a full actual quotation mark is a string. A single character, sure, we can put it in a single one. How about we do like a curly brace for fun? We can store the character value. And remember, behind the scenes, what's stored in memory is actually the numeric value of this. It's the Unicode value or Ascii value you might hear. So everything that's text is stored as Ascii or Unicode. So there's a table. Why ebay.com? That's a really weird ad.
Don't you want to get a Ascii table to put on your wall?
No. Actually not. So the first bunch in the Ascii table, like, no, reject your cookies. Thank you for giving me the option. Are like really special things. We really start caring about them come here or so when we have like actual characters, like the space mark and some other characters you might use, and the numbers, and then some more ones, and then you get to 65 is the letter A, capital A. So eventually we start storing the actual letters that we know and love, and then a couple more special characters, and then the lowercase ones. And I don't know why they didn't come right after. I didn't make it. This has been around for probably longer than I've been alive. Pretty sure longer than I've been alive. I might be surprised. Okay, I kind of want to Google that now. It's okay, it doesn't matter. So you can store an individual character, and what it actually stores is the numeric value of that behind the scenes. Because the only thing we can store in memory is bits. They're on, off, on, off, on, off, right? Which we turn into a number and can store something. So everything will boil down to bits. So with a single character, we store the numeric value. With a string of characters, you store a bunch of numeric values. Right? So if I wanted to write Eric in ASCII, I'd use the number 69 as my character for E. And then if I wanted to be fancy and go lowercase, right, I go find the R is 114, and then an I, 105, and then a C, 99. So you can assign characters like this, and I can also assign, capital E, what did I say, 95? You can assign a character as the numeric value. These are essentially interchangeable behind the scenes. Right? Whether or not you give it the character, it will get translated to the number, or you just give it the number directly. So lowercase I, what did I say, 105, 105, char lowercase. I don't know how to spell my own name, folks. The R comes before the I. Lowercase r is going to be 114. Lowercase I, lowercase c. And again, it feels silly, but like trying to do the word and then the next value, the camel casing, makes them look like they're uppercase. It's all right. Um, 99, thank you. 99. And then I can print them if I want. So I can just print capital E. Now, what you don't want to do is append them together, right? If I do capital E plus lowercase r plus lowercase I plus lowercase c, actually, it might work. I don't think it's going to work. Lowercase c. All right, that's a little long, but here, I'll bring it down a line. And so we can see it. So let's see what we get. See if it prints that or a number. My Java plugins hate me. If you hit run and nothing happens, go to your project, right-click the properties, and this compile on save option, I've never had it work well for me. I don't know why that's... Okay, it's supposed to be helpful. And most of the time it just forgets about it. Let me try that again. There we go. Hey, look, 413. Added a bunch of numbers together. Uh-oh.
So I took it literally.
Yep. Let's try just the E. Uh-oh. Is 95... Did I look at the wrong one? Capital E. 69. Where did I get 95 from? All right, let me try that again. Now we get a capital E. Awesome. So again, if you add them together with that plus sign, it says numeric plus numeric. Adds. So you're looking at the bottom here? I can't actually move that up. Because it stays down at the bottom even if I expand it. I'm sorry. I can move the tab, right? Maybe side by side. Is that tab? I don't actually know where a good place to put that is going to be, because it's going to look really ugly. So let me just leave it here. I'm sorry. But remember, so there's print and there's print ln for print line. If you use print, you don't get the new line at the end. It doesn't go down a line. So if I use print instead, I can print each one of them one at a time. And then my last one, I'll use print line because I want that special new line character at the very end. Maybe lowercase r, lowercase I, lowercase c. So if I print, without print line, the cursor stays where it is and it doesn't go down a line. Print line will take it down a line when it's done. So now I should be able to get my name out. Super interesting. I can spell my last name too if you want. All right. Cool. So again, characters, right? As the individual character with the apostrophes, or even the numeric values, if you want to get fancy. And characters are only 2 bytes long. So the problem with that is you can only get up to a certain number. Now, characters are smart because you can't have a negative Unicode value. So like with our integer values, you can go from a negative to a positive range. With character, it just knows you can only be positive. So we actually get the full range here. So we open up the calculator here. The calculator. There we go. And you go to the programmer calculator. And if you go to bits in binary with the bit switching here, if we do 2 bytes worth and I turn them all on, it's going to see what is the sum of this. So the largest value you can get is, that's kind of small, 65,535 possible Unicode values or ASCII values. So that's a lot of characters, but it's not the full Unicode table. So over time, as we realized like people speak other languages and not everything's in English, we had to expand Unicode. And especially as we started adding emojis and other things. So there's different levels of encoding in Unicode, either the 2-byte or 4-byte notation. So like with 4 bytes, you get billions, right? Yeah, 4 billion some characters. With 4 bytes, we can probably do every letter plus emoji you could ever invent. I imagine. Like 4 billion is a pretty big number, right? So by default, though, Java is using the 2-byte encoding. So just know you can't go super large, right? More than 65,000. This table doesn't even go up that high, but at some point you get other funky characters and things. So you can do all sorts of fun characters if you want. Cool. Right, and then the last type here that you can use, these ones are actually really helpful, are called Booleans. A Boolean is a single bit. It's either on or off, it's true or false, it's yes or no, right? So typically, we'll assign it a true or false, because it is nicer to see that, yes, I'm using the word true, I'm using the word false, instead of assigning a 0 or a 1. If you think like a computer, you want to assign 0 for false, 1 for yes, or true, sure, go for it, but it's usually easier. So this will be true or false. We'll say equals true. I don't know, is that, how about true or false value? You can assign it the word true or the word false. Notice they turn to orange or whatever color you have in your IDE for highlighting. That's one of those reserved words. It has a special meaning in Java. So we can pick one of those, and we can even print it out. And if we print out our value, Java's kind enough to give us the word false when you print out a Boolean, or the word true.
You're not.
False. Yeah, I mean, this is the computer. The computer's not me. Don't believe the computer if it tells you it's Eric. So it's a lie. Remember, we looked at doing some of these comparisons before, right? We printed out, you know, like 42 equals 42. And then we did it in parentheses, right? 42 equals 42. I think we did stuff like this. Like, does a number equal another number in chapter 2? For some basic, you know, here's what's going to go in an if block. We can print those out. Oh, I probably should add like colon and a space. Make it look pretty, right? But we'll see 42 equals 42 is true. Right? It evaluates the expression. So just because I didn't use the word true doesn't mean it's not going to print true. So like when you print things out, you get the nice looking value, true or false. All right, awesome. If you want, you can assign numbers in floating point or scientific notation. It still confuses me most of the time, so I tend not to use scientific notation, but if you're dealing with really big numbers and you need to use scientific notation, go for it. You can do that, and Java's happy with the scientific notation. I'm never going to ask you to do it. A couple notes about Java. So far, what we've done is we've said, hey, I want a value of this type, assign it a value. Like, here's the value I want to store. You don't have to do it that way in Java. Right? Java is more than happy if you wanted to say, hey, here is my string for favorite color, semicolon. That's it. This is declaring the value. I haven't assigned it a value yet, but we've declared it. And Java's going to go say, hey, operating system, I need a place to store this, but don't put anything there yet. Right? Reserve the space for me, hold it. I'm going to put something there later. And then later on, we could, what's your favorite color? And then we can use one of these scanner things. I like calling it keyboard, the new scanner, given system.in, sorry, capital S, system.in. Whoa. Remember, the first time you try and use scanner, it's going to be confused and say cannot find symbol. That's okay, the little light bulb here is really helpful. Pick the add import for java.util.scanner, and then we'll go add this line for you. You're welcome to type it by hand, but I love when the tool does stuff for me. So we'll automatically know, hey, did you mean this one from the Java utility library? Yes, that one, please. Now I can say, whoa, that was cool. Favorite color is equal to or assign it the value of keyboard.nextLine. Right, so I can say, hey, I want a string up here. Now, hey, go give it a value. Or change the value. It doesn't matter if I had a previous value. If I previously said blue, and now I entered something like turquoise, it will overwrite the value. Sure, it doesn't matter. No big deal. But you're welcome to define them here and then use them later. Depending on who you talk to and what they feel like is a good practice, sure, there's nothing wrong with it. Some people will say you should define all of your values the very first thing. So like the first thing you do in main is say, here's a bunch of values. I need a string for this, I need an int for this, I need another string for this, I need another int, and don't give them any values. So like everything is defined first, and then write the rest of your code that goes and gives them values. I don't really care. It's nice and good. It means like you've thought about, hey, I'm going to need a value for this Like, hey, I need a value for number of parties at the guest. Hey, I need a value for number of slices of pizza each guest is going to eat. You probably don't want a variable name that long. Like that 80 characters is a bit long for a variable name, but you can come up with something like average number of slices. I'm sure it's probably fine, and that's nice and descriptive. But don't put like ASPG for like average slices per guest, because who knows what an ASPG is? And I'm going to have no clue. I'm going to be confused trying to look at your code. And honestly, if you like close it down and then come back to it the next day, you're probably not going to remember what ASPG means either. Okay? The worst thing you can do is say, hey, here's my average slices per guest here equals, I don't know, we'll just leave it here. We're going to define it and then leave a comment and say ASPG means average slices per guest. Please, 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 please never do this. If you have to leave a comment telling me what a variable is, it means you gave it a bad name. Right? Okay. Obviously, this is your first programming class. You haven't had people get weird about it.
No, I don't know super specific.
Okay.
You have to do that. That was like what he required us to do.
This makes me cry. And I lost a point back when I was an undergrad. I think I told you the story years and years and years ago because I didn't include a comment. And I swore to myself, that's stupid. I'm not going to make people do it. And I still don't. And the people, other profs who tell me, yeah, that this is good practice, I say, no, it's not. Go away.
Yeah, when he had like 30 points per project dedicated to commenting, and I was just like, are you kidding me?
I mean, it's not a bad habit to comment code.
Especially if someone else needs to look at it.
So our rainbows in unicorn land, where like everything is perfect and magical, it means my names are great enough that you know what it means just by seeing the name, and you don't need to read a comment. And I understand that like it doesn't happen all the time, so there definitely is a place for comments. But the stuff we're doing, it's really simple. Like you don't need to tell me what you're going to do and then do it in code. Now the process of figuring out what you're doing in English and like, okay, I need to do this step and this step and this step is fantastic. Like that's the problem solving that we do. That's why coding is hard, because breaking down a big problem into smaller and smaller and smaller problems, simple enough that the computer can do, is hard work. And that's why software developers make a lot of money. Not everyone can do that, right? It's a skill that you learn to do. And some people have a lot of trouble thinking in that sort of way, that they can take a problem and break it down into smaller and smaller and smaller and smaller pieces and do step by step by step by step. So it takes some practice, and that's okay, right? It's just like a recipe. You just follow the recipe and your pancakes turn out great. Although sometimes your batter's too thin and you add more milk, and sometimes it's too thick, you add more milk, and then it's too thin, you add more mix or more flour, and then you like have 100 pancakes for your family for breakfast. My kids don't complain when that happens though, but like I've got a bunch of kids who like pancakes. Yeah. Six. Yeah, the recipe I use is literally called truck stop pancakes. Yeah, oh, look at that. It's even purple there. I clicked this one a lot. 5 eggs, 5 cups of buttermilk, 5 cups of flour. Like everything's in 5s except for the 6 tablespoons of butter. I just do 5 because it makes me happy. Like it's all 5s, and it's fantastic. So I love this one. Anyway, enough about pancakes. So if you have to tell me what it is, you used a bad name, right? Now don't like average number of slices of pizza a guest will eat.
No one could possibly compute that.
That's very specific. It's a little long. I'm going to be honest, right? We can probably do with some happy middle ground, okay? But don't leave a comment telling me what the variable does. The name of the variable should tell you what it does, okay? I've actually used variables this long before, just so I can avoid using a comment, because it was a really awkward thing. It was like a workaround where you couldn't store a particular value. So like the name of the variable was like, this number is a placeholder because you can't do this, was my name. And I was kind of proud of myself because I didn't leave a comment. You can take it to a bad extreme, I'm sorry. So sure, you're welcome to leave comments. Description things are nice. Generally, we frown upon it in the industry because when you go change code, it's really, really, really easy not to change the comment. So if I go change the variable name because I want to change what it's doing or something here, it's really likely I'm going to forget to change the comment because honestly, I'm focused on getting the problem solved. and I'm going to forget the comments. So we say comments get stale. Code is never stale, because like that's literally your code, right? That's what's happening there. So, like, sure. And again, if an organization wants you to comment everything, smile and nod because they're writing your paycheck or signing your paycheck, right? It's not a big deal. Don't be like, oh no, Professor Eric says never to write comments. You're just going to make us both look bad, okay? Sorry, that's a weird soapbox. So if you want, you can declare values and then set them later. No big deal. So let's do a quick look here. So this might be useful, this sort of checking here for like what you're doing with your project. So I can say, hey, if my favorite color, and remember when you compare strings, don't use the double equal sign. That's how we compare integer values or numeric values. It doesn't compare strings well. Okay, there's lots of reasons. When we talk more about strings, it'll make more sense, but just don't. So if you want to compare it to strings, you say, here's my string variable, you say dot equals, and you can say equals or equals ignore case. If you're dealing with user input, you probably want to ignore case, because who knows if they're one of those people who like to use caps lock and argue with people on the internet. I don't know what they're going to type in, uppercase or lowercase. So I'll say, hey, if my favorite color equals ignore case, blue, then I want to do something. So I open a set of curly braces. Right, this is the if block from chapter 2. So if it's blue, I'll say, hey, that's my favorite too. Right? Else if. So I'm going to say, okay, if it's not this one, else, hey, let's check, does it equal another one? So favorite color, just going to copy paste, right? So instead of blue, how about we go with red? And I'll say, that's my son's favorite color. Sure, we could do some other thing. If it's not blue, if it's red, we'll do this. And then, else if the favorite color is turquoise, QUIOSE or something. It's probably close. I'm really bad at spelling. I'm sorry. I'll just apologize now. That's my daughter's favorite color. Okay. You don't want me to do all 6, but that, you get the idea. Then I can also say, if you want, right, you don't have to, but I can say, if it's not this, and it's not this, well, what's the default? Right? If it doesn't match any of these, I can have an else. If I don't want to, if it doesn't match, I could do nothing. Right? Sure, I'll just say you're special. Right? Sure. If you want an else, you can put the else in. If you only want to do something, if it's blue, red, or turquoise, leave just the ifs, don't have an else. No big deal. Right? Not a problem there. That make sense? So like, hey, what's your size of pizza? You do something if it matches. And then if you want an else, be like, you can't order extra large? Sure, I don't, whatever. Or you can't order that size? Go for it. If you want to leave it off, it doesn't matter. There's no points in the rubric for checking that. There's only points for doing it right if they give you the right value. Now, in the real world, it's really nice to check things and tell people, yeah, you entered a value. I don't know what to do with this. Try again. We're not there yet, so don't worry about it. Okay? So we can try it. So what's your favorite color?
Purple.
Purple. That's actually my other daughter's favorite color. Or one of the other daughters. We got 4. Yeah, so you're special.
Thank you.
I mean, the computer, it's makes you feel good, right? All right, cool. Another cool thing you can do in code, if you want a value and you don't ever want it to change. So we want like, hey, I'm going to set some value and it has a special meaning. I'm going to use it other places here. We can do this thing called a constant. Now, these are very useful in that it puts a nice name to the number. So if you just have a number somewhere in your code, like if I said, oh, goodness, where do I even want to do that? So, sure, we'll say int your number. So we'll ask him to enter a number. We'll say 1 to 99. Okay, so take your number equals keyboard.next line. Remember, that's going to give me not an integer, so it's mad at me. So I need to change it to an integer. So I need to say, hey, you're giving me a string, but I really want it as an integer value. So it's integer parse int. What I'm going to parse is whatever you gave me as the next line. So this will convert it to an integer. Now I have an integer value. Now I can do some fun stuff with it. So I can have an int magic number equals your number times, what is it, times 9, right? I think if we multiply by 9, we can do some fun things with it. So it's multiplied by 9. So, but now 9 here, I don't really know what it is here, and what it represents. This is just sort of what we call like a magic number. I mean, I already call it magic number here, but if it doesn't have meaning, or like you're using it for something special, you should probably put a name to it. So we could use these constants. So we'll say, hey, this is a final int. This is my magic multiple. Now with constants, you do them in all uppercase because you want them to stand out, they're special. And if they're all uppercase, you can't just smush the words together because then it's kind of hard to see where the next one is. So you put underscores in between them. So say our final magic multiple is 9. Okay, we'll take our magic multiple. Oh, okay, no, it's 1 to 9. That's what it is, 1 to 9. So we're going to take your number times the magic multiple. Will get us a magic number. Okay, then what I can do is I'm going to take, hey, I want the number of tens here. So I want the tens place for your magic number, right? Whatever that happens to be. So my tens place is going to be the magic number divided by 10. Right? How many times can I divide 10 out? And remember, if I'm taking an integer divided by an integer, I'm only getting an integer result. So this is the whole number of times that I can divide 10 by. So if your number was 27, right, I'm just getting the 2, the 20. 2 for the tens place. Okay? And then my ones place, we're going to look at a new operator. So if you want to divide things, right, you get the whole number. If one of them is a double, you get or a float, you'll get the number with the decimal place. If you want the remainder, magic number, you use this modulus operator, the percent sign. Modulus 10 gives you the whole remainder of the division. So it divides by 10 and then gives you the remainder result. That's called modulus. The integer remainder. Maybe we'll put that up a line. So modulus will give you the integer remainder. So we can tell them. So your number times 9 has a, let's do tens place. In the tens place and ones place in the ones place. Oops, one more plus here. You get all the right pluses? Oh, it wants the, what does it want? Parenthesis expected. Oh, right here. So this one, I'm missing a plus. So I've appended these two together, but I didn't have one over here. I need another plus sign to say, hey, take this string, append this string in. Okay, so the hint there saying it was expecting parentheses was not very helpful. Sorry, I can bump that up. All right, so
That's weird looking parentheses.
where is it?
We had to add a plus and it was telling me.
Oh, yeah.
Parentheses.
Yeah, the errors are not always the most helpful. Okay, so we'll just spit it out. Hey, I found the tens place, found the ones place. So let's try it.